So, hello everyone. Today we continue to prepare for technical interviews practical part, and today we will review how to solve carfleet problem, which is of type medium. And here I have prepared a draw just for visualization. So, what's the idea of this problem? So, we have got a bunch of cars driving down the same lane toward one finish line, called target, and each car has its own starting position and speed. The catch is that a car can pass another car that's ahead of it. So if a faster car catch up to a slower one in front, it has no choice but to slow down and just tag along with it, and they become one fleet. Basically, a convoy, in other words. So for the rest of the trip, they will drive with the same speed. What we actually need to figure out is how many separate fleets end up crossing the finish line. So here the most important idea is to understand that this car, which starts from the most closest position, will become the limit. So his time of arrival to the finish will become limitation for cars which are behind it. Why so? Because let's imagine that this car will arrive to the finish in let's say in 2 hours, and these two cars will arrive to the finish in 1 hour. But because they cannot pass this car, they will catch up this one and will slow down, which will mean that by the end they will reach the finish in 2 hours, and all these three cars will be in one fleet. So again, the most important idea that the car which is ahead is his time of arrival will become limitation for those who are behind. Even if they are faster, they will become one fleet and will arrive in the same time. So now let me show you the illustration of this algorithm. So first of all, we will need to create an array, binary array where we will store the position from where car starts, and we will store how much time this car needs in order to get the finish without any obstacles. So let's do this. So here is let's imagine that this is positions which we have. So position 10, 8, 0, 5, 3. Our target is 20, and speed for every car from each position. So for example, for position 10, the speed will be 2 miles per hour. For position 8, it will be 4 hours per hour, and so on. So we will put here the position, and now we want to know how much time this car from position 10 and speed 2 will need in order to get the target. And because the speed of this car on the position 10 is 2 miles per hour, it means that we will arrive this position 20 in just 1 hour. So we make this calculation and put the result here, and the same thing we will do for all our cars from every position. So car from position 8 and speed 4 will need only 1 hour in order to get the target if in front we would not have any obstacles, and so on, so on, so on. All right, so now we have for each car from each position how much time they need in order to get the target. And now, because how I already mentioned, cars from the top, so from the position which are closer to the target, will become a limitation for those cars who are behind this position. And for that, we will need to store this position descending in order first to process this one, then this one. Let me show you. So we sort positions. Now we have first we will process position 10, then we'll car from position 8, 5, 3, and 0. So that's the idea. And now when we will make calculations, we will need two variables. One variable we will store how much fleets we already found, and another variable we will need in order to keep the limitation of car which is in front of the rest cars. So let's say we'll have variables current fleet time, which will, how already said, it will be the limitation time, and fleet count, how much fleets we have already found, because this is the main goal of this task. So let's start. We start from the first car, which is the closest from the closest position to the target. And because this is the first car, it will form a first fleet, and the limitation time will become 1. Yeah, because this car will need 1 hour in order to get the target. And even if a car from the position, for example, yeah, let's suppose that this car would have here 2 hours. Yeah, and even if car from the position 8 would need 1 hour, we still will form a fleet here, and this car will arrive to the target not in 1 hour but in 2, because time of the first car is limitation. But okay, we'll see it a little bit later. So again, we update our we increase our fleet count, and we update our current fleet time. All right, now we go to the next element. We go to the element to the car on the position 8, and we check how much time it needs to get the target. And we can see that this car from the position 8 and car from the position 10 will arrive in the same time, which means that this car will catch the first car, and then we will go and we'll arrive to the finish in the same time. So they form one fleet, yeah, because they arrive together in the same time. So it means that we still have one fleet. We don't need to increase this variable again, because still we have only one fleet, but with 2 cars from position 10 and car from the position 8. And the current fleet time still remain 1 hour, because it's a limitation time from the first car which is ahead of all. Okay, now we go to the next. Actually, let's increase. Okay, now we go to the next car from the position 5. And we can see that this car will arrive, in case if we would not have any obstacles in front. In best case, this car would arrive in 7 hours. And we can see that this car is much slower than cars from the front, which means that this car from the position 5 will never catch cars from the first fleet, which means that we need to create another second fleet. And now the limitation speed will become 7. So let's do this. So now we have found 2 fleets, and the limitation will be 7, because now it becomes the head of all the rest cars, and the limitation is 7 for them. Now we go to the next car from the position 3, and we can see that in best case, if we would not have any obstacle in front of us, we would arrive to the finish in 3 hours. But because in front of us we have a slower car, it means that we will catch this car, but because we can't pass it, we will slow down and we will arrive together in 7 hours, which means that again we still have only 2 fleets. We don't need to increase this counter, and the limitation time will remain 7, because car from the position 5 and his time is our limitation. So then we go to the last car from our line, from our road, and this car starts from the position 0, and in the best case, car would arrive in 20 hours, which means that it will never catch up these cars which arrive together after the 7 hours. And it means that we again need to increase our fleet count because it will be a separate fleet, and the limitation hour will become 20. So that's the idea of the algorithm. Our result will be 3. We will have 3 fleets. And now let's proceed and check how we can implement this in Java. So here I have prepared the signature of the method, and now the first thing what we will do, let's check if position is not null and if the length of this array is not equal to null to 0, because if it is, we just can't return 0 fleets. So let's make this check. So if position is equal to null, or if position length is 0, then in that case let's return 0. Okay, simple check. Now let's create a variable where we'll store the length of this array with positions. So let's do something like this, just in order not to write always position length. Okay, perfect. And now, how I already showed you in the previous visualization of the algorithm, we will need an array, binary array, bidimensional array, and in that array we will have our elements will be formed from 2 values. It will be their position and how much time the car from that position needs to get the target if in front of that we don't have any obstacles. So let's create this bidimensional array. Let's call it position type, and it will be double position time. Okay, and here we'll have n elements and combinations of 2 values. So for each position in that bidimensional array, we will have 2 values. One is the position, and another is how much time do we need to get to the target in the best case, if we would not have any obstacles. So now we want to iterate through through our positions and to fill with data this bidimensional array, because we need to calculate for every position how much time it would take to get to the finish without any obstacles, because we don't have it right now. So let's create our for loop. We'll start from index 0, and we will iterate n times because n is how much positions we have. And now let's first fill the p-dimensional array position time. So the first value will be position. We have this data from our array with positions. So we can do something like that. Here we'll have 0 position. All right. And now we need to fill for each position the time, because we haven't done it right now. So let's do this position time. So let's calculate this, and the formula will be target minus position, current position. This we will need to take in square, divide by target, right? And let's put here double. Okay, perfect. And now when we have this array, what remains for us to do is to sort it by positions, because how I already mentioned and showed to you that we will start to iterate from the top element, which is closest to the target. So let's do this. Let's sort our array. Position time. And we need to sort by position. So that's it. And now when we have our binary bidimensional array with all data unsorted, we need to perform calculation. So first let's create our variables carfleet, where we'll store the fleets which we will find during the iteration, and time limit. Okay, perfect. And now we can start to iterate for our bidimensional array. So right, and now we want to check if time limit is less than position time, the current position time. So if it's less, it means that this current car from current position and with this time, for example 2 hours, will not catch up the car from the ahead, because the time limit from car from the ahead is less than current one. Yeah, so let's imagine that we compare 1 hour with 2 hours. We will never catch up the car from front of us, because it will arrive much faster than we will do this. So it means that we need to increment our carfleet variable, and we need to update our time limit with current time. So time limit should be double actually. Yes, and in the end, we just will return our car fleet, how much car fleets we have found. So that's the implementation. I hope I explained it clear. And now let's check the complexity. So the time complexity is O n log n, and the space complexity is ON. So I hope this video was helpful for you, and we will see in the next one. Bye.